Lesson 9. The Trapezium rule. If a function can't be integrated algebraically, you can use a numerical method with trapeziums to approximate the area under a curve. Let's consider the curve y equals f of x. The area under the curve from b to a would be the integral from b to a of y multiplied by dx. If we can't integrate this algebraically, we could approximate the area under the curve using trapeziums. If we split up the area into n number of trapezia with equal width h, so the next value would be a plus h, then a plus 2h, and so on and so forth, until we get b minus h. And each one of these y values would correspond to these x values as y1, y2, and up to yn minus 1. Then we can approximate this area using these trapeziums if we lined them all up. For instance, the area of the first trapezium, using the area for a regular trapezium, would be a half multiplied by the width h multiplied by y0 plus y1. And so this makes the area under the curve approximately equal to a half h of y0 plus y1 plus the area of the next trapezium, which would be a half h multiplied by y1 plus y2 plus a half h of y2 plus y3, and so on and so forth until we get a half h of the last two y values, yn minus 1 and yn. We can factor out the half h to get a half h multiplied by y0 plus y1 plus y1 plus y2, and so on and so forth until we get 2 plus yn minus 1 twice plus yn. Then as you can see, there are 2 of all of these y values except for the first one and the last one. And so we can rewrite this as y0 plus yn plus 2 lots of y1 plus y2 up to the second to last y value. And that's the trapezium rule. The formula allows you to approximate the area under the curve and is given inside of the formula booklet, where h is the width of each strip calculated by the end value b minus the star value a over the number of equal strips, and yi is equal to f of the first x value a plus I lots of h. Let's do one example. The diagram shows the graph of y equals sec x. The table shows values of x and y from x is equal to 0 to x is equal to pi over 3. Use the trapezium rule with 4 strips to estimate the area under the curve from x equals 0 to x equals pi over 3 and state whether this is an overestimate or underestimate. Using the trapezium we just learnt, the area will be equal to the integral from pi over 3 to 0 of y dx, which we can approximate as a half multiplied by the width, which in this case will be pi over 12, multiplied by the first y value, 1, plus the last y value, 2, plus 2 lots of the middle y values, 1.035 plus 1.155 plus 1.414. And so this will be pi over 24 multiplied by 10.208, which is about 1.34 units squared to 2 dp. And this would be an overestimate. That's because the graph is convex, and so if the points are joined together, the trapezium would go over the curve instead of under it, so it would be an overestimate. If it's concave, then it would be an underestimate because the lines would join under the curve. And that's about it.